Okay guys, welcome back. We're doing question 13 from the 2023 paper. Just a quick look at the marks. It's worth 10 marks and they're suggesting 10 minutes. So that's probably suggesting this kind of a difficult question. Let's see. Okay. So let's read the question. It's sort of a nice picture there. We have a goat and somebody climbing, cliff climbing, and certainly brave. A very dramatic picture. Okay, anyway, a company is making a large rectangular poster as shown in the diagram on the right. So what is a rectangle? It's a quadrilateral with 4 right angles and with opposite sides of equal length. The top section will be a square image. So it's a square and then a little bit sticking out of the square. So this reminds me of completing the square technique. So I'd say that might be a choice down along, but maybe not. There's so many methods with quadratics that we can take our choice or do more than one, and it'll be interesting to see the marking scheme. The bottom section will be rectangular of height 0.5, and you're just checking for split. You're just split attention, check that it's also on the diagram, you don't need to add it, which will have the sponsor's logo. The width of the poster is X meters wide. Write the total height of the poster in terms of X. Okay, so because it's X wide and this is a square, then I think you'll agree that this is X, so we can start our problem solving now. So what you do in your problem solving like this is you write down anything that you know from the given information. So I know that there is X, and now I can look at the total height as being X plus 0.5. So it's X plus a half is another way of writing it. Now the total area of the poster is 50 meters squared. Show that then in that case 2x squared plus x minus 10 equals 0. Okay, well we know that it's x wide and it's x plus a half. So that's 50 when you multiply them together. So let's set that up. X multiplied by x plus, now is there something here with centimeters? That's a half a meter, 50 meters squared. No, we keep going. It's in centimeters. Did he mention centimeters anywhere? No. Okay, we keep going. I'm just wondering where that 100 was. The 50 is going to come into it. So x plus a half. When we multiply them together, we get 50. Okay. Now, we don't like the fact that this is a half, and we'd rather it was a whole number. So I'm going to multiply across by 2. And I'm going to multiply this factor by 2. I'll do that somewhere on the sides. I'll do it maybe in the more traditional way that you might be inclined to do it. So x by x is x squared if you're distributing, plus a half of x with this distribution, and you're finished distributing now, so that's equal to 50. And now we could certainly say let's clear the fraction. So let's clear the 2 now. Let's double, giving us 2x squared plus x equals, doubling remember, 100. And now bring the 100 back and you get 2x squared plus x minus 100 equals 0. I would have doubled here, giving myself 2x plus 1, and I would have doubled here. Same result, 2x squared plus x minus 100 equals 0. Okay. Solve this equation to find the value of x. Give your answer in meters, correct to the nearest centimeter. So suggests it's going to be a decimal. It suggests that it isn't going to factorize and we should use the minus b formula, which we're going to do. So in that case we call it ax squared plus bx plus c. You might remember it's page 16. that? Page 20, isn't it? Okay, making little mistakes and challenging yourself to try and remember those things is all good, because I probably won't say it ever again that it's on page 16. Of course it's on page 20. So you have ax squared plus bx plus c, and then you have your formula that says x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now you can put values in the calculator, but I'm just going to write it out because it's probably what we're going to see in the marking scheme. So we say that a equals 2, b equals 1, and c is equal to, must be very careful there with the sign. So let's do minus b is minus 1, plus or minus the square root of b squared is 1 squared 1. Now minus 4 times 2 is minus 8 times minus 100 plus 800. Okay, all over 2a all over 4. Okay. Now I think you'll agree we're not allowed to have a negative value. So one of these, this will throw up a negative value, and it will not be allowed because distance has to be positive. So we'll go with the positive one only. So we have this, and I'm going to do it with the method in the calculator as well because it's just so easy and so many of you are using it. So it's going to give me the exact same result. So what I'll do is I'll go 2 stored to A, 1 stored to B, and negative 100 stored to C. Something annoyed me there. I just want to see something. 2 stored to A, and then I was allowed to do 1 stored to B, but it wouldn't allow me to put in a negative. So I'd have to push AC, and it's a good idea to push AC between all of them anyway. Minus 100 stored to C. Okay, so I think I learned something there. And then I'm just going to use the formula. First and foremost, it's a fraction. It's minus, recall B, alpha B, minus B. I'm going to go with the plus version, square root, alpha B squared, minus 4 alpha A alpha C. And you can guide yourself here and you can check yourself here because it just looks like the formula. It is the formula. 2 alpha A. Okay, it equals, you get your third expression and you get your, now sure enough, if I go forward there to turn that plus to a minus, but I can tell you now that that will give a negative result, which we dismiss because x can't be negative because x is a distance. Okay, so give your answer in meters correct to the nearest centimeter. So we're in meters already, are we? We are. Correct to the nearest centimeter will be to here, and that we'll have to round up. So 6.83 2,000 places is what they asked for, and this is in meters. Wasn't that mean there? Ooh, correct to the nearest centimeter. Okay, how are we doing? Let's grade ourselves, see how we're getting on against the model answers. There are only model answers, there are alternatives as well. Question 12, we're finished. Question 13. Okay, we got x plus 0.5, or equivalent. And we got this. And we got 6.83 meters to the nearest centimeter. Great. Okay. And it's all about not what method you use to solve these things. It's about the more general principle. And the big thing there was rejecting the negative version here. You don't even have to put it in. We did have it on our calculator, but we didn't even write it down, that negative 7.33. Okay. See you in the next one, which will be the last question in 2023.